Atomic formulas. Atomic formulas denote basic relations, such as x equals y and x is less than y, which can be true or false depending on the values of the variables occurring in the formula. There is a resemblance to the atomic formulas of propositional logic, only this time the atomic formulas carry much more information because we have the variables. Somewhat vaguely, one can say that formulas that do not contain connectives and or not, if then, if and only if, and also do not contain what we will later call quantifiers, namely for all and exists, are atomic formulas. Atomic formulas may have internal structure that we cannot analyze with the means provided by predicate logic, as in the sentence, "Tomorrow there will be a sea battle," and "it is possible that it will rain." Here are some examples of atomic formulas of predicate logic. X is yellow. X is taller than y. 4 less than z. X equals 10. X, E, Y. X less than z. P0x. Variables. Variables are used in general statements, such as if x and y are natural numbers, then either x less than y less than x, or x equals y. Any two distinct vertices are neighbors. Every tile is red or blue. Variables are also used in existential statements, such as there is a natural number x such that x greater than 10 to the 10, and x is a prime, which means it has no divisors. Some vertices have no neighbors. Some tiles are left of a yellow tile. Variables are denoted by x, y, z, u, v, and so on, possibly with indexes, x0, x1, and so on. Assignments are functions that assign values to variables. When we consider the truth of a formula with variables, we must have a structure in mind, otherwise the concept is meaningless. For example, it does not make sense to ask whether the formula x, e, y is true or false, because we ought to know what values of x and y are, and in addition, what the meaning of e is. Even if we know that e is the edge relation in a graph, we have to know which graph we are talking about, since there are lots and lots of different graphs. So let us assume we have a structure M with universe, also denoted by M, such as a set of tiles, the set of vertices of a graph, integer numbers, rational numbers, or something like that. We think that the variables range over the set M. Fixing the value of a variable is called an assignment. Mathematically speaking, an assignment is a function that maps variables to M. Here is a table of 3 assignments of values in the integers for the variables x, y, and z. S0 maps x to 1, y to 5, and z to 1. S1 maps again x to 1, y to 1, and z to 3. S2 maps x to 1, y to 2, and z to 4. We can present such values nicely in the form of a table. The assignment S0 of the above table satisfies the formula x equals z because S0x equals S0z. That is, the assignment S0 maps the variables x and z to the same element. Likewise, assignment S1 satisfies the formula x equals y because, again, S1 maps the variables x and y to the same element, namely 1. In general, we define that the assignment S satisfies the formula x equals y if S gives the same value to x and y, that is, Sx equals Sy. Similarly, an assignment S satisfies the formula Pnx, where Pn is a unary predicate symbol in the vocabulary, if Sx is in the set Pnm, the set that interprets the symbol Pn in the model M. And an assignment S satisfies the formula Rxy in a model M if the pair Sx, Sy is in the set Rm, the binary relation that is the interpretation of the symbol R in the model M. We will look at examples in a moment. Let us first, however, look forward a little bit. Statements built up from variables using logical operations, connectees and quantifiers are called formulas. We have already met the simplest formulas, namely equations, like x equals y, x equals x, y equals z. We call them atomic formulas. Atomic because they are the basic ingredients of all formulas. We have also met the second kind of atomic formulas, x less than y, rx, xey, pn of x. These are also called atomic formulas. More complex formulas come in the next lecture.